So today we have Dr. James Dyke, one of our assistant directors of the GSI, who is an associate professor in music arts systems. Who I really appreciate because he doesn't shy away from difficult topics and he doesn't sugarcoat it, as I think we're going to find out today. And he doesn't shy away from climate change and the impacts that it's already having, and the fact that it's already bad and it's going to get worse, especially if we keep telling ourselves stories about it that let us not do anything about it. So yeah, with that, James, go ahead.
Thanks, Pappy. Thank you for the invitation. I am not Kelly, so if anybody wants to just quietly leave, if you've turned up to the wrong talk, then I won't take it personally. So I'm going to talk for about 45, 50 minutes, I think, and then we've got a Q&A. So how to begin? The Paris Agreement has failed. It's not going to keep humanity safe from climate change. Warming is going to significantly exceed 1.5 degrees Celsius, and there's no credible routes to return humanity back down to that level by the end of the century. And moreover, mainstream climate policy seems to be doubling down on an approach that could make things much, much worse. Thank you for coming to my TED Talk. For the remaining 45 or maybe 50 minutes, I'm going to expand a little bit about that and argue why we need new plans that address the climate and ecological crisis, and that requires new ways of thinking. Some of what I'm going to talk about relates to a collaboration, a kind of a long-term collaboration I've done with these two people. So Robert Watson, or Bob Watson, he still is a climate scientist. At one time, he was the chairperson of the Intergovernmental Panel on Climate Change. He's largely retired, but he doesn't seem to be spending any less time doing important research. He does a lot of synthesis stuff now, taking climate change impacts and biodiversity, ecosystem kind of impacts. And Wolfgang Knorr, who at one point was a climate scientist, he looked at kind of biosphere climate interactions, and he has now largely left academia to go and do other things. Back in 2021, we wrote an article called Climate Scientists' Concept of Net Zero is a Dangerous Trap. That generated quite interesting discussions, quite animated discussions. And what we decided to do earlier this year is kind of update that with this article. I don't write the titles, right? So I didn't write the title that the concept of net zero is a dangerous trap. I'm not trying to walk away from it. And they didn't write the title about the overshoot myth. You can't keep burning fossil fuels and expect science in the future to get us back to 1.5 degrees Celsius. There's a number of reasons why I didn't write that title. One, it's too long. And also, Andreas Malm and Wim Carton have just published a book called Overshoot, which is really, really good. So if you want to know anything about overshoot, then you might want to read that paper, but you certainly want to read their book. And I think it's more than just overshoot. It's about the entire approach to this thing that we call the climate and ecological crisis. Does this going to work, do we think? No, it doesn't. I'm not really sure what this is doing then. So let's remind ourselves, back in 2015, the surprise outcome of the Paris Agreement of COP21 back then was not only did the international community agree that there were urgent and immediate needs to address the climate crisis, such as avoid dangerous climate change, but what the definition of dangerous climate change was, which was well below 2 degrees Celsius. And that's been, certainly I would argue, since the COP in Glasgow in 21, that's come to be interpreted as 1.5. So when we talk about the Paris Agreement, the highest ambition of the Paris Agreement, the Paris Accords, 1.5, right? With reference to that kind of mid-19th century amount of warming. 1.5 to stay alive, right? You hear that all the time. Climate policy, national climate policy, and then how that gets dissolved down into organizations, including this university, is that we must limit warming to no more than 1.5 degrees Celsius. And that was seen as a surprising but important outcome of Paris because, well, one way to interpret it was an act of largesse from the rich global north to the developing, so-called developing global south, the acknowledgement that beyond 1.5 degrees Celsius, some of these places won't exist anymore because they will literally be under the sea as a consequence of sea level rise. So low-lying island nation states. Well, of course, unfortunately, neither greenhouse gas emissions nor concentrations in the atmosphere nor average global temperatures have been listening, and it's now almost certain or increasingly likely, I don't know if you want to put a number on it, but this year will not only be the warmest year that humans have ever recorded, but it will be the first year that exceeds 1.5 degrees Celsius since that kind of mid-19th century baseline. Doesn't mean that long-term warming is exceeded because of natural variations. Maybe 2025 will be a little bit cooler. But as I'm going to go on to argue, I don't think there's really any doubt that that long-term threshold is going to get breached now. 23 is interesting, 24 is interesting. I mean, I don't want to spend too much time on this. Maybe some people might have something to contribute in the discussion, right? But I think it's fair to say that we are far from having a complete understanding, and that goes beyond the bits you can just attribute to natural variation as to why 23 was, in some instances, gobsmackingly bananas warm, right? That was the expression that Zeki Housefather used to describe the September anomaly. So we need to remember natural variation. We've got to zoom out a bit. And when we do zoom out, we find there is a surprisingly simple and very robust relationship between cumulative emissions. So we've got cumulative emissions on the bottom. That's not time, that's cumulative emissions in essentially trillions of tons, so thousands of gigatons. And on the vertical axis, we've got the change in global surface temperature. And you can see as emissions increase, then temperatures increase. And that's a remarkably kind of relatively simple relationship. You can imagine have all sorts of different relationships, but at least within the climate regime that we're in now, if you keep adding carbon dioxide to the Earth's atmosphere, then there's a kind of almost commensurate, not necessarily linear, but kind of increase in temperature. So what that means, if you can see the past's climate response, and if you look into the future, and if you want to limit to warming to, let's say, no more than 1.5 degrees Celsius, then you win the realms of these. Is this going to work? Right, yeah, these things. The SSPs, the shared socioeconomic pathways, these are kind of integrated assessment, kind of future climate scenarios. If you want to limit warming to no more than 1.5 degrees Celsius, then you've got to put no more than, let's say, 3 trillion tons of carbon into the atmosphere. If you carry on, maybe once described as business as usual, burn all the coal, oil and gas you can get hold of, and then you're going to exceed, 4.5 trillion tons, and you're going to be exceeding 2.53 degrees Celsius. So this notion of carbon budgets, how much carbon you can put into the atmosphere, has become absolutely central to how we think about the climate crisis and how we are meant to be responding to the climate crisis. And yes, bear in mind that there are still quite large error bars, because despite sterling work of some very, very clever people around the world, some of them are here, right? There is still an awful lot of uncertainty around things such as equilibrium climate sensitivity, changing over time, but there's still a lot we don't know about the climate system. Okay, so time is running out. It's 5 minutes to midnight, it's 1 minute to midnight, it's 30 seconds to midnight, right? Every COP, there is the declaration that this is the COP that we need to make the progress. Last year, it was in United Arab Emirates, and here we have the president of COP28 remind everyone that we need to be flexible, define common ground, come forward solutions and achieve consensus, and never lose sight of our North Star, right? It's all about 1.5. That's what I'm going to stay laser focused on. But is it though, right? Was 1.5 really his North Star? Because the COP28 president was also, Dr. Sultan Al-Jaber is also the CEO of ADNOC, which is the state-owned oil and gas corporation, which whilst he was making that statement was in the process of expanding the amount of oil and gas that it was going to extract. At a time of rapidly vanishing budgets for 1.5, you also have the explicit attempts to increase the amount of extraction of hydrocarbons, which would gobble up that budget faster than ever. And it's worth also reminding ourselves that when it comes to our contributions to the climate crisis and also who's most vulnerable, there are vast inequalities. Every year, Oxfam updates this kind of analysis, and what you essentially find is that the richest 10%, in terms of consumption emissions, are responsible for about 50% of it. A relatively small fraction of humanity is responsible for the problem, and it's the poorest 50% who make hardly any emissions contributions who are going to be suffering the consequences of that human-caused climate change. And not only that, not only do we have a kind of, obviously a sort of understanding of vested fossil interests to continue to extract coal, oil and gas, you also have what is propelling that, which is a significant amount of finance. So billions of dollars, tens of billions, hundreds of billions. Every now and again, there's an assessment of how much has been committed since the Paris Agreement 2015. Whichever way you look at it, you have got billions, if not trillions of dollars continuing to flow into the financing of new oil and gas, in particular, also some coal. But there can be no dispute that that oil and gas must stay in the ground if we are to have any chance of limiting warming to no more than 1.5. So we end up with a strange world, this kind of double-think world where 1.5 is our North Star, and at the same time, we're doing everything that we possibly can to extract as much oil and gas and to burn it and therefore go through that carbon budget. How do you solve such a crisis? How do you kind of keep that cognitive distance in check such that you don't have some kind of either internal mental breakdown or the perceived tensions somehow throw climate policy apart? How do we do that? Well, I think we've done that through net zero. Net zero has been a useful idiot for the facilitation of the continued extraction of coal, oil and gas, of the hydrocarbon economy. And this doesn't mean that the architects of net zero, or the science of net zero, or the scientists, the policymakers, the people involved in the Paris Accords have been disingenuous or in denial or disinformed. I'm extraordinarily grateful to all of those people. But collectively, when you look at what the concept of net zero has become, then it is a potentially dangerous way in which we look at the current crisis. So what do we mean by net zero? Because net zero doesn't just mean, let's say, carbon neutrality. If I burn a ton of carbon because I go on holiday on a jet aircraft, I can't offset those emissions just by planting a bunch of trees. We're actually in the process of publishing something about that now around the university's response around offsetting, which I think is going to be an important contribution. But net zero is much, much broader. It's much broader because it uses something called the science-based targets. You might have heard of the SBTI, the Science-Based Targets Initiative. So it begins with this idea of cumulative emissions and this notion of the zero emissions contribution or commitment. If we get to net zero, then essentially there will be no further increases in temperature within those error bars. That doesn't mean that global climate change has stopped. You know, the thermal inertia in the oceans, the melting of glaciers, this thing is going to be going on for thousands of years. But if you want to stop increases in temperature, then you've got to stop the emissions. And if you can work out to take some carbon out of the atmosphere, then you're allowed a certain amount of, let's say, residual emissions. But the SBT is a dance between science and society. And I kind of describe it like this. Science has had a really important role, primarily through the IPCC, to tell society what do we think are the consequences of warming in terms of sea level rise, drought risk, extreme floods, things like this. Then society is meant to determine, well, how much warming is acceptable? So what's dangerous? And there's obviously been different interpretations. While some people, they will still argue that 350 parts per million is what constitutes safe or dangerous. Other people will say 2. You still ask Bill Nordhaus and a bunch of other kind of economists, they'll say 3 is not only the kind of threshold of dangerous, but is actually in some respects optimal. So there's an awful lot of value statements that go in there. Well, however much warming you think we need to limit, then we can, scientists, determine what your budget is within the error bars, right? And then it's meant to be back to society, determine, well, we've got a budget, how do we allocate the slices of the pie? How do we allocate the slice of the pie, given that a relatively small fraction of humanity is responsible for the vast majority of those cumulative emissions? Annex 1 countries, developing nations, you can imagine it's a very, very complicated and perhaps intractable problem. I don't mean to make light of the fact that there hasn't been much progress in that respect, but this is the dance between science and society. Now, in all of that, we need to come back to some kind of simple truths, or maybe some brutal truths around what 1.5 means in terms of carbon budgets, and therefore how fast we need to decarbonize. So there's been a series of these kind of charts. Robbie Andrews has been producing them for a while, and also Glenn Peters has got some nice visualizations. And what they show is that in this instance, if you want a 66% chance, so you want a 2 in 3 chance of keeping warming to, let's say, at or below 1.5 degrees Celsius, then given historical emissions, if you were to start decarbonisation around 2000, you would have needed to decarbonise around 4% a year. Challenging, but possible. If you wait a bit longer, for example, they say starting mitigation in 2019 will require monumental mitigation rates, and within about a decade, there just isn't any carbon budget left. You didn't decarbonise in time. Well, of course, emissions haven't suddenly started to go down. They haven't stabilised. They're actually continuing to increase. So fossil fuel CO2 emissions in 2023 were the greatest ever recorded. So they are going up. They're continuing to break records. So now when we do these kind of assessments, not only does that curve get steeper, but you'll also find your likelihood changes. You won't really find reports for 66%. Now we're on 50%. Right? Now we're basically a flip of a coin. And depending on which research you read and when it is being published, that carbon budget is getting smaller. It could be around 200, 220, maybe under 200 gigatons now. And at current rates of emissions, that could be gone within about 5 years. But again, we could be lucky. We could have a bit more time. At the same time, we could be unlucky. We could have already passed that budget. We could have already blown the budget. We could have already entrained the system into long-term warming of no more than 1.5. Now, this isn't any secret, right? The IPCC has been kind of reporting about this, and it's certainly in the literature and in the academic community. This is AR6, the last big assessment report from the IPCC, and you can see that SSP 1.9. This is the most optimistic scenario. I mean, it's the one that nobody believes, but it's the most optimistic scenario. And you can see the best estimate for midterm warming is this kind of overshoot. But by the long-term warming, by the end of the century, maybe the best estimate is this kind of Paris-compliant one. So the most optimistic scenario that at least the IPCC can report on is one in which temperature is going to exceed 1.5, but then they're going to be back down by the end of the century. So net zero has essentially become overshoot. It's an approach in which we will allow, I guess, because I mean, this is happening to us, not because of a volcano, right? It's human emissions which are causing climate change. So we will allow, or maybe even willingly engineer the situation in which temperature is going to exceed 1.5. And then it's the deployment of something called CDR, carbon dioxide removal, which is a type of geoengineering that I'll talk a little bit more later, will drag temperatures down by the end of the century. So this is kind of what it looks like. Instead of that essentially vertical cliff face of decarbonisation, we now have what to a policymaker seems to be something what we call policy relevant. And this is the kind of things that politicians like, because it doesn't mean radical or large-scale changes to any of our industrialised societies. It is proposed, because decarbonisation is going to follow this brown curve. So this is the continued emissions of carbon dioxide, largely through, let's say, industrial processes. And I'm mindful of the fact that I don't really talk about land use, food systems, but that's important as well. So decarbonisation happens, it happens extremely quickly, yeah? But you can see that it doesn't happen anything like such that we reach net zero by 2050 or maybe 2040. And you can still see there is the burning or at least emissions of greenhouse gases or carbon dioxide at and also beyond the end of the century. And of course, the reason they propose we can do that is because net emissions will be following this solid black line such that around the middle of this century, we will end up in a net zero and then an increase in the total amount of carbon dioxide that's going to be removed from the atmosphere. So this isn't just offsetting. I'm going to plant some trees to offset the carbon which is going to be emitted when I get on a plane. This is offsetting in the sense of offsetting decades of delay. So we will somehow remove carbon dioxide from the Earth's atmosphere to essentially offset the failure to mitigate now. So 1.5 now relies, it's always relied, right? The highest ambition of the Paris Agreement, given how policymakers interpreted it and the policy that came out of that, always relied, and arguably it had to rely because you would have never have gotten most nations, certainly the industrial nations, certainly a nation like the United States would have never have signed up to the Paris Accords, which required immediate, large-scale, rapid reductions in CO2 emissions. It would have never have signed it. So this idea of an overshoot and a correction was a supposed on-ramp to get those kind of nations on board. And the Paris Accords, the Paris Agreement, the framework was such that there'd be there'd be a period of nationally determined contributions, an increase in ambition, a ratcheting up of ambition such that we would eventually bend that curve. Well, it hasn't happened, and I just don't think it's going to happen in the time that we need. But how is overshoot meant to work? So there are some particularly quite technical elements of overshoot. So these things, message, image, remind, GCAM, aim, and which, are the names of the integrated assessment models. The integrated assessment models are things which feature prominently in the IPCC, in particular Working Group 3, and they're the way in which a significant fraction of the academic and policy and industry community has thought about, well, how could we decarbonize, or what could be the different kind of futures? So this future kind of over here, future in which we see emissions continue to go up, would produce by the end of the century around 5 degrees Celsius or even more, right? The Paris compliant kind of scenarios, these ones down here, have us, yes, around the middle of the century getting to net zero, but then you can see we're in a period of net negative. Depending on how far we overshoot and what your temperature ambition is, if it's 1.5 or 2 or something, then towards the end of the century, we might be removing as much carbon dioxide as we currently put into the atmosphere today. And how are we going to do that? Well, magic, right? And I don't mean to be impolite, and I don't mean to be disrespectful to some of the very, very important work that goes on in the areas of geoengineering and carbon dioxide removal, but I do argue that there is no credible route in which we're going to be taking tens of billions of tons of carbon dioxide out of the Earth's atmosphere. But that doesn't mean there is a lack of ideas about how to do this. And I call it the wacky races, right? There's two main approaches. One, we're going to take carbon out of the atmosphere. And the other one is we're going to try and offset some of the consequences of those increased concentrations through things such as solar radiation management. There is an awful lot to get through, and it's an exciting time, actually. It's a very exciting time. I'm currently writing reports on geoengineering, and there are many, many, many startups, companies, ideas, research groups, in some instances, individuals, who have got some idea or notion of how we could reduce concentrations of carbon dioxide. And I think that is good in and of itself. I mean, what's not to love about being able to reduce concentrations of CO2? We've got, at the top left, we've got notions of biochar, pyrolysis to lock up the carbon in, let's say, agricultural waste products and then put it on land, right? We could afforest, we could plant a lot of trees, we could reforest, we could restore degraded woodlands, we could grow biomass and then burn it in power stations, then capture the carbon dioxide that comes from the chimneys and then bury that part of the kind of the BECCS, the bioenergy carbon capture storage approach. We could be affecting the chemistry, the alkalinity of the oceans, which would increase the amount of carbon that gets brought down. We could accelerate or enhance the natural weathering processes, which in the absence of humans would mop up all that extra carbon dioxide, which is the good news. The bad news is it's going to take about 100,000 years. So let's make that run faster by crunching up mountains and spread it over fields. We could increase fertilization of algae and other photosynthesizers in the oceans by dumping millions of tons of iron filings in the sea, or the this is where most of the excitement and an awful lot of the funding is coming from at the moment. Direct air capture, we could strip carbon dioxide directly out of the atmosphere and then concentrate it and then geologically sequester it, put it deep, deep underground. Some of these things will work. Some of these things will do some things that we want. Some of these things will do things that we really don't want. Let's say they are problematic in some respects and they're promising in others. But more generally, what they offer is a time machine. They offer policymakers and wider society the promise that we can basically just go back in time to a land of climate past in which we didn't continue to fail to leave fossil fuels in the ground. And that's been an argument that I think David Ho's made really quite compellingly, and he continues to do important and useful work in this area. So David research interests around the potential of the ocean to sequester carbon, but at the same time, he's also very outspoken about how that could be used, misused, abused by policymakers and wider society to be offering promises for the climate crisis that just do not exist. So that's overshoot, but then you've got this something that I call overshoot plus, right? New and improved overshoot. Because if a CDR is not going to do it in time, then what other things could we deploy? And this is the idea that we could, as we spin up attempts to remove carbon dioxide from the atmosphere, we'll also deploy things like solar radiation management, which will shave off, which will just reduce those temperatures a little bit more. So this is the kind of the right-hand side. So these are essentially routes to try to affect the energy balance of an entire planet, which sounds exciting and cool until you realize that it's the planet that you actually live on. The main routes are going to be changing the albedo of the Earth, and that would be, for example, marine cloud brightening, spraying seawater into the air in order to increase the number of reflective droplets of clouds. It could be putting disco balls in orbit around the Earth. It could be putting a massive space mirror in between the Earth and the Sun. There are other approaches which would essentially allow more energy to escape the Earth. And that's, for example, the thinning of certain clouds at certain latitudes. Or what's got most of the interest at the moment is sulfite aerosol injection, spraying, for example, sulfurous compounds or maybe other compounds, because the idea of spraying sulfuric acid into the atmosphere freaks some people out. But that's just one kind of material that could be used. And the motivation there is to produce highly reflective particles that would simulate the impacts of volcanic eruptions. Pinatubo is the canonical example. That eruption, that very large volcanic eruption, reduced global temperatures by 1/10 of a degree for a number of years. So if volcanoes can do that, why can't we, right? What this means is that you've got the kind of the CDR approach. Well, let's get to net negative emissions. So even if we decarbonize everything, we're now in the overshoot scenario where we need to be able to remove carbon. So let's use those kind of multiple CDR routes, but then also SRM to basically try and shave that temperature off. Now, of course, SRM by itself would be a foolish thing to do. It'd be like trying to reduce the impacts of a house fire that you're within by turning the air conditioning on. That won't work, right? So whenever we talk about solar radiation management or other kinds of geoengineering, there is always the assumption that it must come with mitigation. And certainly in defense of that academic community, they go to great efforts to always explain that this technology, these approaches are interesting, they're promising, but if you do not decarbonize, if you do not mitigate, then you are potentially going to make things much, much worse. But there's a more fundamental problem with overshoot, and I'm sure many of you here know what I'm going to talk about, is that this notion that, well, what goes up might not necessarily go down, or the idea that the climate and Earth system regimes are kind of symmetrical beyond the peak. And of course, that's not necessarily the case. You know, one of these things is not like the other, right? Decarbonisation through the rollout of solar or wind or maybe hydro or nuclear fission or even nuclear fusion is not the same as removing carbon dioxide through direct air capture, such as the Climeworks plant. They will be subject to much, much different kind of challenges and risks. And I would argue it's only relatively recently that we've seen, at least in terms of the publications, people wanting to put something in the public forum, people be willing to speak out about this, is there is increasing skepticism about overshoot. I will just move on. I'm doing my best to be polite about this. So it's all those, what do you think politicians were going to do when you provided them a route to say that, don't worry, we're going to keep humanity safe, but we'll actually keep extracting oil and gas? What do you think they're going to do with that? They're going to continue to extract oil and gas. Overshoot has kind of facilitated this approach in mainstream climate policy, where on the one hand, we can keep humanity safe, but at the same time, we don't actually do the things required to keep humanity safe. Now, there's been specific, I mean, just quite recent discussions around overshoot risk. We did talk a bit about these. In our overshoot paper earlier this year, we talked about the assumption that policymakers make with regards to the removal of carbon dioxide through these natural land and ocean-based sinks. So around half of all the carbon dioxide that we put into the atmosphere is removed naturally. About a quarter ends up in the sea and a quarter ends up in land-based sinks. And policymakers and these kind of scenarios and future kind of policy scenarios assume that these things will continue to work. And there has been for quite some time, good evidence and good reasons to think that as warming increases, some of these sinks will decrease in their efficacy to be able So we say that if natural sinks begin to fail, something they may well do in a warmer world, then the task of lowering global temperatures may become even harder. And, unsurprisingly, there has been some evidence, there's been some recent events in which some of the land-based carbon sinks are, if not collapsing, there's quite a lot of drama around some of this reporting, they might not collapsing, but they're not just behaving as well as they could. And that's really important. And I think this is a risk that's almost been entirely missed by many who work in the climate policy space. Because when they think about the Amazon, they think about the dieback of the Amazon. They think about, well, what if the Amazon switches from its, it's kind of bi or tri-stable state from like broadleaf evergreen forest to a savanna? That's going to release an awful lot of carbon dioxide. But for sure it will, yeah. But even if it doesn't become a net source, the fact that it's slowing down its removal of carbon dioxide could put an absolute spanner, could put a swinging wrecking ball through all our efforts to limit warming to no more than 1.5 or any amounts of warming in the future. But the Amazon is a good one. It gets talked about a lot as a potential tipping point. And as we know, if you're here, you have to know, because surely this is one of the world centers of climate tipping research, the Earth system is full of these. Now, we know that the Earth system is full of these, and those things could make things much, much worse. In the context of forest dieback, we also see the direct relationship between these potential tipping points, or at least their reduced efficacy to remove carbon, and the overshoot approach. And we do that through this kind of notion of offsetting. Offsets are everywhere. So earlier on, I said we're going to publish something, hopefully this week, around the use of carbon offsetting for the university's net zero strategy. And they are very, very, let's say, problematic. We've already seen a number of offsetting schemes that use forests burn down. So a couple of years ago, there was very large-scale forest fires in California, and some of the forests that burned were being used to offset the emissions of some very large technology companies, right? And it's only been relatively recently that there has been a significant shift on publics and the policy, well, maybe not the policy attitude yet, to offsets. I mean, late as January 2023, you got Fiona, who's a very, very esteemed and well-respected environmental writer, she's at The Guardian, making the case that yes, they're flawed, yes, we know they're problematic, yes, they can be subject to abuse, right? But we need offsets, right? Because we're just not decarbonising fast enough. Well, go to January this year, and now you've got some even policy response that recognises the use of offsets are just potentially counterproductive, right? They're counterproductive. The Guardian has been leading on some of these reports. This comes from a lot of the work of Patrick Greenfield. The vast majority of environment projects most frequently used to offset greenhouse gas emissions appear to have fundamental failings, suggesting they cannot be relied on to cut planet heating emissions, according to a new analysis. There's been work that's concluded that when you look at the largest organizations within the voluntary carbon credits market, 90% of them are, from a climate perspective, just junk. They don't do anything with regards to concentrations of CO2 in the atmosphere. They might do other things. There are people who argue that they're really important for financing, protection of forests, maybe even the protection of indigenous peoples. I don't dispute that, but if that's what you want to protect, then that's what you should be paying for, rather than some notion of a fantasy that you're having some kind of impact on the climate. So offsetting is problematic, to say the least. We have a whole bunch of technologies which are being proposed, which range from, I guess we could kind of see how we could do that, all the way to essentially science fiction. We're seeing the continued facilitation of a policy approach which refuses to grasp reality and actually think about how we can rapidly decarbonize. And what we're left with is an approach of overshoot and overshoot plus. And this is when I think things become particularly problematic or particularly worrying. Because if you think about the future that we are heading, so warming is going to exceed 1.5, and given continuing trends of emissions and financing for new oil and gas, and the absolute dysfunctional nature of the UNFCCC, and yet another COP, which is largely a waste of everybody's time, with regards to mitigation, I don't doubt that there's important work to be done in regards to adaptation, loss and damages. We're entering a world, let's say by the middle of this century, towards the end of the century, we're going to see increasing impacts. The storms that we've just seen recently devastate areas of Spain will be repeated in other places around the world. We're going to see significant displacement of people. We are potentially going to witness the greatest movement of humans in all of human history as a response of climate disruption. We should expect to see significant internal political conflict. I mean, this is the January the 6th insurrection, and I wouldn't attribute this to climate change in any way, shape or form, but it just so happens that the 47th president is going to be a presidency or administration largely underpinned by vested interests, which include fossil fuels. And as a consequence of enforced displacement, maybe immigration, decreasing living standards, we can see that political climate is going to become an awful lot more problematic, let's say. And there are reasons to think that armed conflict, international conflict, is going to increase as there is increasing conflict over water supplies, food supplies, energy supplies. Now, somehow, we're meant to believe that whilst all this is happening, whilst we're spending trillions of dollars, let's say, in a desperate attempt to mitigate, as we realize just how much time we have lost, maybe even more on adaptation, and maybe even more on loss and damages, we will at the same time be implementing and delivering technologies which affects the entire climate and energy balance of the Earth. I think that insults my intelligence. I don't have much intelligence to insult, so I think that really is a reckless proposition. But it gets worse, right? It gets worse because we've had a kind of a laser-like focus on tipping points, certainly at Exeter, and I think this is excellent. And I'm very, very proud to be part of an institution that's playing that role. The emergence of negative or dangerous tipping points in the climate system have been vital to today's discourse on climate change. At the same time, we're also seeing positive social tipping points, which is proving to be an important contribution to this idea that maybe societies could respond a bit faster than we thought. Maybe societies could decarbonize quite a lot faster than we thought previously. What there hasn't been a tremendous amount of research on are the negative social tipping points, because when you look at our globalized, industrialized, highly complex society, when you see how it interacts and how utterly dependent it is on the provision of food and energy and water, you begin to see how climate change, as that classic threat multiplier, could be producing change in social systems which make the situation much, much worse. So this is some work that was led by Victoria a couple of years ago that came out of some of the global tipping points work. And this is just one kind of semi-random figure that showed the impacts of climate change on mental health. The more we look, the more we realize that climate change is doing pernicious and difficult things to people. And if it's affecting people's mental health, it's affecting also, I think there's some very interesting research that's looking at how it's affecting humans' moods, emotion, levels of antagonism. All these things happening at the same time as we're increasing the burdens of people and societies, increasing the scale of the challenge, means that the harder the challenge becomes, the harder it is for human societies to effectively respond to it because they become less capable. And so what you end up with is what I call the derailment risk, is that the failure to deal with the climate change crisis means that ever greater diversion of efforts from mitigation, which is ultimately what we need to do. And so there are essentially three types of risks. Climate change risks we know all about, right? Transition risks, economists know all about. They're the risk of stranded assets of decarbonizing too fast. But we also have derailment risks, the inability for us to do the things that we needed to do such that the green transition or the energy transition or mitigation actually gets derailed itself. That movement into that attractor, that space, that phase space, could prove to be catastrophic. And it's one in which policymakers are almost entirely ignorant of. I mean, that's just one. I've been doing some work, quite a lot of work with Laurie Laybourne, who's one of our fellows here, but he's largely based at Chatham House. And he has spent years now talking to policymakers, in particular UK politicians and civil servants, to try to understand, for example, how do they perceive climate change risks? One thing he did, he presented a whole bunch of scenarios around the collapse of the AMOC, or component of that, the subpolar jar, and showed those policymakers what that could mean in terms of, let's say, food security for the UK. Because even if the entire AMOC doesn't collapse, if the subpolar jar was to stop working in the ways that it has, we could be looking at a really, really different change in terms of temperatures, but also precipitation, and such that we might not be able to grow the kind of crops that we have done previously in the UK. It could have a potentially catastrophic impact on food security. And these things are not hundreds of years. We'd be looking at risks that might be emerging maybe around the middle, if not before this century. And these kind of risks are nowhere near. They're just not on the radar at all. So this idea that Overshoot is producing these whole new series of risks, Overshoot Plus is producing a whole new series of risks. In some respects, we're kind of doubling down and making it worse, means that we must absolutely define some kind of limit. Maybe the limit was 1.5, maybe it was 1.3. And that's not a new idea at all. So at the time of the Paris Agreement, and certainly soon after, academics like Oliver were saying, look, this isn't a blank check, right? You can't just say, because the Paris Agreement is about the sources and sinks of carbon by the end of the century, that doesn't give you license to exceed it by any arbitrary amount. Unfortunately, that's not what's happened, right? I must emphasize here, metaphor, right? Metaphor. This is a metaphor. I don't mean that scientists are actually directly paid to produce kind of scenarios or science which unlocks political inaction, but is a kind of a metaphor, right? And isn't metaphor derived from the Latin, which means transaction or something? There has been this very transactional relationship between academia and policymakers, in which academias have been put into a little box, which has been told to be policy relevant. And policy relevant has been interpreted as decarbonisation can only happen so fast. Okay, but at the same time, that community has generated the most fabulous future scenarios in which we can almost, move the Earth with regards to its orbit around the sun. I mean, that's the level of kind of geoengineering that's in some instances being proposed. So that's enough negativity. What kind of positive contributions do I think we may have? Well, the first one, I mean, yes, it's obvious, isn't it? It often gets skipped because we assume that everybody, of course, we leave the fossil fuels in the ground. But look, if you don't leave them in the ground, then I think every other attempt at climate policy is going to fail, because as soon as you extract those hydrocarbons, they will be burned. That is why you are extracting them. And obviously, this is the crux of the problem. But we can't fool ourselves to think that the number one priority is to leave them in the ground. Somehow, in terms of stranded assets, we've got to get fossil fuel corporations and petrostates to walk away from trillions of dollars of hydrocarbon assets they would do everything they can to exploit. The first thing is I think we should actually ditch net zero time. This idea that what we're trying to do is reach some point by the middle of the century, like 10 years, 20 years, 30 years, in order to establish some end of century threshold, facilitates the kind of political license to delay. To that end, I think when it comes to the SBTI, and this organization and other organizations, there should be this laser-like focus on what are you going to do right now to reduce your emissions. To that end, I would always advocate for twin targets. If countries want to come up with their net zero plan, then it should be very, very clear how much carbon they're seeking to offset, and then what their actual decarbonisation proposal is, because they continue to hide lack of ambition and lack of progress behind a very, very vague net zero target. So making twin targets will actually help identify that. I am either agnostic about geoengineering research, or I'm actually quite keen of it because I like to do that research and I think it's interesting, right? But what we must not do is include these highly speculative approaches within climate policies, because these policies are affecting the real world now. So I would remove them all, right? So if you've got some kind of country's net zero target for 2050 or 2100, or if you have those integrated assessments, those kind of integrated assessment scenarios, those IAMs, I'd remove them all. And you can put them in there once you can show how it works, how it will be monitored, how it will be verified, how it will be reported, and what the impacts of that technology will be on other planetary boundaries or other aspects of the climate system. And then finally, I would argue that we need to be honest with ourselves about how net zero has been used and how overshoot is being used and will be increasing, which is nothing fundamentally different needs to happen. Steady as she goes, don't need to do anything radical, don't need to threaten economic growth, you don't need to challenge vested political interests. And also that means once you dig into that, we also need to highlight the vast inequalities when it comes to those who are responsible, and I put myself in that bracket as well. I've done very well out of the industrialization, thank you very much, and I still, despite some feeble efforts, have a pretty large carbon footprint. The vast inequalities when it comes to wealth and carbon emissions. Okay, so now I'm wrapping up. I just want to address one of the critiques of some of my earlier work, which was that I'm picking on academics, right? And in that respect, I'm kind of punching down when really I should be punching up. I should be punching down at academics. I should be calling out politicians, maybe industrial leaders, maybe even particular fossil fuel companies, maybe even Shell, right? They seem to have done some spectacular rowing back on their climate ambitions. And I don't mean to punch down on anyone. What I wanted to was to get them to rise up. So since that publication in 2021, I co-founded an organization called Faculty for a Future. And the motivation was to try to empower academics and academia more generally to take a much more, let's say, engaged and effective approach in the climate and ecological crisis. So if anybody wants to learn more about that, I'm very happy to talk to you. So what this means is that I think we can avoid the worst impacts of climate change. The fact that we're going to warm, I think, significantly above 1.5 and we're entrained probably into more danger doesn't mean that it's game over. It doesn't mean that civilization has got to undertake some kind of unavoidable collapse. I think we actually can, but at the same time, we have to admit that no, we didn't, we failed. And one of my constant frustrations is that we fail to acknowledge that failure. We keep on keeping on saying just one more heave, right? We need to increase our ambition. We look back at increasing emissions and we say, no, this year is going to be the year in which we're going to bend the curve. It's not working, it's not going to work, and it's going to get worse. And so we need to come up with another plan. Now, the idea that we're going to exceed 1.5 or maybe even 3 by the end of the century is no secret to climate scientists, right? And it's only been relatively recently that we've been seeing the consensus around 1.5 and Paris fracture. I think Trump's election has probably been the thing that's done it now, but we could see these narratives. I mean, it's been a couple of years ago now, wasn't it, that the Economist had it on their front page. We very, very quickly need to come up with effective, coherent, productive narratives around what 1.5 means and what the Paris Agreement and what is it that we're trying to do. Because if you continue to say 1.5 is still alive, whilst global average temperatures are above 1.5 and the weather's going bananas, you're not really going to be very convincing, right? And the idea, I mean, in terms of climate scientists, I mean, this is a pull quote from a recent piece from The Guardian, Gavin Schmidt. I never thought 1.5 was conceivable. I thought it was a pointless thing. And I'm totally unsurprised, like almost all climate scientists. I used to upset people when I said, I don't know anyone who thinks, I don't know any climate scientist who thinks we're going to limit warming to 1.5, right? I've been saying that for a number of years. And it always used to exercise people. And I've lost count of the number of times I've had a conversation with somebody and they've said, essentially, of course warming is going to exceed 1.5. Well, we can't say that yet. And my response has always been, so what can we say? And then it kind of dissolves into, well, you know, Paris and inequality. It's just not working. Now, the risk is if we don't come up with something, if we don't come up, if I may, others will, right? Jem Bendel's deep adaptation, we're doomed, right? The best thing you can do is just get to grips with it and maybe learn how to become a farmer or something. Or Washington Post article, right at the top. Scientists have said that we can cool the planet back down. Now they're not sure. Oh, it's our fault. I'm sorry, right? Because we promised that we could overshoot from an arbitrary amount of warming. Now that there's been a kind of an increase in publications, somehow it's our fault and not the consequences of repeated climate policy failure. Christiana continues the stubborn optimism line. And I love the little cartoon that you've got climate change, right? And solar radiation management is going to protect carbon dioxide removal, until such times it can grow into a big, strong hero and save us from climate catastrophe that way. I think there's loads of alternatives. One is the political risk. So this is a very successful politician, and he's been subject to pointed attempts and attacks such that he should resign. And he was the president of, oh, he still is the president of Valencia, right? Catastrophic failure to understand climate risks. Politicians have failed to understand that climate risk isn't something by the middle of the century or by the end of the century, because we have deeply understood or misunderstood the magnitude of climate risk. Climate risks are now, right? And they're going to be proximate and urgent. I think this is a lever that we could pull. Because let's remind ourselves, you know, for many of us in the community, let's say, our understanding or engagement with climate change goes back to Jim's kind of landmark testimony in 1988. Which was an important contributor into the, you know, the kind of the Rio conference in 92. Remember what came out of that? What is the United Nations Framework Convention on Climate Change meant to be doing? What's the point of all of this? Well, the ultimate objective is the stabilization of greenhouse gas concentrations in the atmosphere at a level that will prevent dangerous. We are trying to stop the dangerous interference in the Earth's climate. That's not what we're doing. That's not what mainstream climate policy is doing. It's actually increasing. We are saying that we can cause a problem like this, and unlike every other kind of environmental problem that we've solved by just stopping the pollution, we're going to continue to pollute, we're going to continue to interfere, but now we're going to additionally interfere in another way, right? It's a classic example of magical thinking. So this is where the title slide comes in, because this is a scene, it's a recreation from a traditional Greek play, and it was a trope. It was a often used plot device in these plays of the time, in which you would see a hero be put in some kind of impossible spot, and then they would be delivered from near death by a god, right? A god would appear on a chariot and then take them away to safety or something. So prevalent was this that it used certain particular kind of machines. So trapdoors or cranes that would kind of crane gods in and then save the hero and take them away, such that they came to be called Deus Ex Machina, the machine of the gods, right? What we are doing in proposing some kind of correction from Overshoot or Overshoot Plus, we're proposing that we will create, in some instances, almost science fiction, fantastical machines that will somehow fix all the problems that we have for decades been unable to do. And the critique of this kind of machine of the gods approach is nothing new. So back in, well, sometime between 408 and 334 BCE, Antiphone said, when they don't know what to say and have completely given up on the play, just like a finger, they lift the machine and the spectators are satisfied. You know, over 2,000 years ago, we knew what a crock it was. It's just they can't be bothered to figure out some other kind of ending. The risks of our use of this kind of Deus Ex Machina is not just a bad review. It honestly could be civilization itself. And so the risks, I think, could not be much higher. Thank you very much for your attention.
James, questions?
We've got 6 minutes.
Yeah, we don't have a tremendous amount of time. We've got Pasha, and we've got almost 100 people online, so we are going to take questions from
Well, I don't mind hanging around for a bit. So unless we need to clear the room, I'm happy to.
We can do that. So, yeah.
How do we get those scenarios, overshoot scenarios, out of like the next, like the AR7 report or whatever, the next IPCC Working Group 3 report, like as scientists?
You affect the composition of Working Group 3. That's the, so the last report made interesting changes. There were interesting advances, and let's say the presentation of thinking that it also includes the kind of the summary text, because it included people who were looking at things like, you know, reduced energy demand scenarios, relaxing the assumption that you need continual economic growth. Because if you have baked into your integrated assessment model that you need continual economic growth, then obviously if your economy is twice as big in, you know, in the next 30 years, then your decarbonisation is at least twice as hard. And so people like, you know, Julius Steinberger has been looking at assessments. Well, if you relax that assumption, and maybe there could be, in some instances, maybe even a decrease in energy material consumption in some of the world's richest places to give more room for other nations, then you might need less recovery from the overshoot. So I don't know about IPC working group politics, but I think that's the kind of evolution of thinking that we might already be seeing.
Okay, I'm just gonna, are you happy to take 2 questions? at the same
I'll do
time?
whatever you tell me to do.
So online, Donna Kell is asking, is a radically managed degrowth possible? And your question?
Okay.
Yeah, just go ahead.
All right. My question is that actually recently there are some paper from London Business School like talking about the ESG rating. So basically the paper mentions that ESG rating is actually doesn't work anymore. Like it's just rubble, and we have like a greenwashing business like more and more. So my question is that in a sense, could you give us a sense of like maybe your ideal economics or ideal like business like should be to, you know, like to fix the climate change?
I don't know about my ideal politics. I suppose I would politely try and my requests are humble. I think we should just start at where we are and what's happening rather than what we imagine we might be able to affect. So, I mean, look, if you were to make it clear that if we want to limit warming to no more than 1.5, we're going to have to do this, then probably you're going to get a whole bunch of organizations, companies, corporations say, well, we don't want to limit warming to 1.5 anymore, right? That's what they'll do. And in fact, that's what we've seen. So there's that sugar rush of declarations of climate emergency and net zero targets around 2018. And now as companies and organizations have worked through what that actually means, well, then they increasingly used offsets, and now the confidence in the offsets, in particular the voluntary carbon credit, you know, market is just almost collapsed. If you take that away, then you're left with some really hard truths, which is, okay, you're either going to undertake some potentially quite difficult or structural changes in your organization, or you're just going to boot the target down the road, and that's what we're seeing. They're just going to boot the target down the road. Well, okay, at least be honest about it. At least we know that you didn't want to limit warming to no more than 1.5. It was always 2 or 3. You know, at the moment we're in this kind of phony war, right, in which we're all these claims being made, but until you see concrete steps to leave the fossil fuels in the ground, then I don't think there's been as much action that many people would claim.
So how about a radical managed degrowth?
Well, some people just assume that's some sort of recession or global recession or slump or something. So what degrowth is or isn't, I think needs an awful lot of unpacking. I'd prefer, I mean, I'm quite agnostic about it, but you could certainly make the case there's an awful lot of rebalancing, right? You've got hyperconsumption in some parts of the world. In other parts of the world, you've got a significant fraction of the population that doesn't have access to electricity. I mean, in some respects, there's more than enough to go around. It's how it's distributed.
I can take another one online. Oh, there are too many online now.
That's
Wait.
That's it, run away.
Thank you for that. It's a quick question about like the policy relevance of research and like what the goal, so like as starting out as a PhD, is there a risk when your aim is to have policy relevant research that can have applied impact, or industry relevant research that can have like a meaningful message to give people who are in decision-making seats like interesting and relevant advice or data? Or is that a risk of like a narrative delay around like what you're saying? It's like actually it can compound the delay risk.
That's really, I mean, it's an important question. It's a tricky one because as an early career researcher, I think you'll be subject to different responsibilities than me. Right. So I try not to fly anywhere, and I don't want to engage with certain people because I've got, I mean, the fools here have given me a permanent contract. I mean, my benign, you know, my lovely employers. So I'm
Shout out.
I'm not in the situation of you know, being on that treadmill of generating impact and getting grants and, you know, having to be in certain places at certain times. So I don't think it's fair for me to say that you shouldn't be doing those things. I would argue that there's more than one ways to generate impact. And yes, going to some junket in Westminster or, you know, Dubai or something is one way. And so, you know, in terms of career progression and CV, that's going to be important. But there's lots of other ways too. And so there's no lack of alternative approaches and also organizations that you could engage with.
Right, so 2 in 1. Who are the national or global politicians or policymakers who are already in this space and are therefore able to persuade others? And John is also asking, how do you see market forces operating as well?
I don't think there's many mainstream politicians or any politician who've actually got any levers, hands on the levers of power that's doing anything remotely appropriate, because they can't be, because if they were, they wouldn't be there. That's at risk of sounding a little bit circular. They're, you know, the groups around the Green New Deal. I mean, the Green New Deal was an idea that I think came out of the UK Labour Party, hibernated for a while, ended up Democratic Party and transformed itself into the IRA, the Inflation Reduction Act, which, okay, I mean, does something. So there's no lack of people and organisations, or you've even got in the UK, I think still operating, the All-Party Parliamentary Group on Limits to Growth, right? So there's some, you know, potentially quite radical and exciting thinking even happening within MPs in the UK. So they're there, but in terms of, you know, being in ministerial office, I just don't think they've got really much latitude at the moment, but who knows? And what was the one about market forces?
It was just how do you see the market forces operating, particularly with renewable energy taking economic choices away from fossil fuels?
Oh, right, yeah. So somebody told me that they were the CEO of a solar company, and they said the reason people are taking our products is not because it's green, but because it's cheap. And so you are seeing the exponential deployment of solar just because it is so much cheaper, right? It's the cheapest form of electricity we've ever made. And so that's happening, right? Irrespective of any climate policy. I completely believe that, right? And you look at other renewable technologies as well. At the same time, you need to turn the fossil fuel tap off, right? It doesn't matter if you've got exponential growth of solar, if at the same time you've got increasing exploitation of fossil fuels, because the climate system doesn't care about how much you generate renewably, it only cares about the emissions. And that problem, turning it off, represents a fundamental challenge to market-based approaches, because you are having to get organizations to leave value, right, or to leave resources, which they will try everything they can to exploit. And that perhaps is the limit of your market-based approach. There has to be a mandate. There has to be some kind of mandate, whether it's a carbon tax or rationing. I don't know what it is, but it seems to me a kind of a problem that you can't expect the market to address. And I mean, look, I think there's abundant evidence now that the energy majors aren't doing it. Fossil fuels are incredibly profitable still. Right.
Yeah. Okay.
There was a question.
Okay. All right. Should we do one more question?
Yeah, I mean, if anybody needs to go, I mean, feel free.
Yeah, because we've also got tea and coffee outside.
Oh, right. Okay. Well, make it quick then. Yeah.
Short question. It's just, did you have any particular comments on how the new Labour government's doing climate-wise so far?
I mean, it's the noises they've been making about energy, you know, nationalising bits and pieces. That seems to be very sensible. I think there's a lot of good things that we would hope to see come from this government in comparison to previous governments, because previous governments were quite so bad. I do.
So it's just that the bar's really low, basically.
Yeah, I mean, when it's, you know, when you have to dig it up out of the ground. So that's good. I don't even try and take issue when Starmer gave a speech. Was it last week? He said, you know, nothing has to change. You know, we can read. I understand why he wants to say that we don't need to see any large-scale behavioural change, you know, because it is such a politically contentious issue, you know, 15-minute cities, telling people you can't eat meat, things like this. I just don't think that's true, right? It's just not true. And at some point, some politician has got to get the gumption to stand up on a populist platform and talk about, you know what? We could tax some of these enormous corporations who are destroying the planet for you and your kids. And at the same time, we can address fuel insecurity, fuel poverty, air pollution. We can give you better places to live. It frustrates me why we find that such a difficult proposition. It's better. There you go. It could be better.
All right, cool. So thanks everyone for all your questions. And online, you've had like a lot of messages and resources being posted. So thanks for that. And let's especially thank James for this amazing